As we continue with transformations, our next stop is to look at horizontal stretches and reflections. Now, horizontal stretches and reflections simply means that your graph gets wider or narrower. Just like the vertical stretches means it gets taller or shorter, this one gets wider and narrower. Let's have a quick look at what it looks like. Here I have the graph of y equals square root of x. And a horizontal stretch, watch what happens to that a value as I stretch it. If it gets bigger, that a value just moves in the x coordinate moves. It doesn't change its y coordinate, it stays the same height. And you notice when I reflect it, it now reflects about the y-axis. So it's on the other side. I'm going to talk about reflections here in a little bit. Now we go back and look at the equation for a horizontal stretch. General form is y equals function of b times x. What I want you to notice this time is that our constant, our stretch factor, is inside multiplied into the x. If you look at your vertical stretch over here, in this case the constant was on the outside. So what this means is we multiply x by that b value before we put it through the function. Whereas on the vertical stretch, after we took the x value, put it into the function, we multiplied the output, or the y value, by a. So in this one, our x values change. The one thing you have to be careful though is it does not change by a factor of b. This means it stretches by a factor of 1 over b. So you're stretching it by the reciprocal of your b value. If I look at it when I look at numbers, if my example is, let's use a different color, y equals square root of 2b, of 2x, that means my b is going to be 2, it's that number right there, but its factor is 1 over 2, the reciprocal of that. So what that means is my graph is going to get half as wide. That's a key point you have to remember. You have to remember that the factor is the reciprocal of your b value. Let's look at the animation. So here we have the square root of x, the graph. As I move my b value, now watch what happens. As my b value gets bigger, my factor should get smaller. My b value gets bigger. Notice how the graph is compressed. So the example I just did, b was 2. That a value is moved over. It's half as far as it was before. So it means the whole graph has been squished further to the left. The height of that point hasn't changed. It's just moved further to the left. And if I move my b to a number less than 1, notice how the graph is stretched horizontally. So you have to remember it's kind of goofy, and it is the reciprocal. So if I look at a horizontal stretch, when I'm going to put it into a table of values here with some points, let's start with y equals f of 2x. Now in this case, b is going to equal 2, so my factor is 1 over 2. So what I do is I apply that factor to the x value. So my new point, it becomes, my x changes by a factor of a half, negative 2 comma negative 1. This one becomes negative 1 comma 0. 0 times a half, well, that stays at 0. 2 divided by a half gives me 1 comma 2, and 4 times a half gives me 2 comma 3. Notice how my y values didn't change, only my x changed, and it changed by a factor of a half. If I move on and look at y equal f of 1/2 x. Now in this case, b equals 1/2, so my factor is reciprocal of that, or 2. So in this case, my points are going to be -8 comma -1, once again timesing the x by that factor, -4 comma 0, 0 comma 1, 4 comma 2, and 8 comma 2. So all of my x values changed, but none of my y. Now along with horizontal stretches also come horizontal reflections. Key point to noticing a horizontal reflection is that if b is negative, if it's anything less than 0, we're going to have a reflection about the y-axis. Just like a vertical reflection reflected about the x-axis, horizontal reflections reflect about the y-axis. So what it could look like is it could look like y equals f of -x. That's a simple reflection. Or it can look like y equals f of -3x. Okay, notice how there's a negative in front of the x. Or it can look like y equals f of -3/4 x. Still a reflection about the y-axis. So going back to my graph of y equals the square root of x, watch what happens when I move my b into the negatives. So it was at 1 there, the a value, as I move my b into the negatives. If b equals -1, I've got the exact same graph reflected around the y-axis on the other side. So when my x value was 4, now my x value is -4. It's a simple reflection. And then you can also have a stretch mixed in with that too. So you have stretch and reflection at the same time. Remember, your factor of your stretch, especially with the horizontal ones, is the reciprocal of your b value. So if I want to look at this from the point of view of points, it ends up looking like y equals, my x value gets times by a -2 instead of just, by a factor of 1/2. Remember, it's reciprocal. So what I end up with is 2 comma 1. This one ends up being 1 comma 0, 0 comma 1, -1 comma 2, and -2 comma 3. Should not be a -3, that should be just regular 3. Let's fix that. Notice how this value and this value, same factor, just one has a positive and one has a negative, are exactly the same, just with different signs on the x values. Y value still hasn't changed. It's just the x value that's changing. And just like if I go over here, these values are going to be 8 and -1, 4 and 0, 0 and 1, -4 and 2, -8 and 2. Now don't forget, we do have a set of invariant points again. If I look at these points right here, you'll notice that it doesn't matter what stretch I applied, the point didn't change, whether it was a reflection or a stretch. Those are all values on the y-axis. Any point that is on the y-axis is not going to change. It's not going to be stretched. It's not going to be reflected. Those are invariant points. And if you are looking at a graph and trying to figure out what your stretch is or what a horizontal or vertical translation happens to be there, it's good to know what those invariant points are and see if they have moved. If they have moved, then you must have a translation or a shift, because a vertical stretch will never change an invariant point on the x-axis, And a horizontal stretch will never change an invariant point on the y-axis.